Hi everyone, I am here with your 624 lesson, How Can I Rewrite It? Combining Like Terms. In lesson 623, you looked at different ways that the perimeter of algebra tiles can be written. You also created different expressions to describe the same perimeter. Expressions that represent the same perimeter in different ways are called equivalent expressions. Today you will extend your work with the writing and rewriting perimeters to more complex shapes. You will rewrite expressions to determine whether two perimeter expressions are equivalent or different. As you work today, keep these questions in mind. Are there like terms I can combine? How can I rearrange it? How can I visualize it? So 6101 says build each of these shapes using algebra tiles and look carefully at the lengths of the sides. So if you have your algebra tiles cut up from a few lessons ago, you can build them, but they are built on your paper, so you can also just refer to them here. Part A says sketch each figure on your paper and color code the lengths that are the same. Which figures have side lengths that are different than those you have measured before? How are they different? So I want you to go ahead, you don't have to re-sketch these, but you can color code them right here on your notes. Okay, so go ahead and pause the video and color code your side lengths that are the same. If you're back with me, you have color coded your sides. So the biggest question here is, do any of them have side lengths that are different than those you have measured before? How are they different? So looking at this figure 2, we have this side length right here that I'm shading, and you can't really see, but this side length right here. We know that that whole side length is X, but it's overlapped by this unit tile. That's new. That's something that we have not gone over yet. Same thing down in number 3. We have this side length right here, which again, we know that side length is X, but it's overlapped by this unit tile right here. So that is where they are different. So we're going to say the side lengths where an X length and a 1 length join. That's where they're different for us. Flip it over. Part B says label each length on your paper. Discuss with your team how to label the lengths that are different than those you have measured before. Explain your reasoning. So go ahead and pause your video and try B. You're doing it for all of the figures. If you're back with me, you should have labeled every side. So this should be X1, X1, X, and X. For number 2, you should have 1. This whole side length right here that I drew my pencil over is X, but it overlaps 1, so it becomes X minus 1, 1, 1, 1, 1, and X. And moving down to 3, we have X, X, 1, 1. Again, this whole side length is going to be X minus 1, 1, 1, 1. Gotta get that unit tile. 1, 1, and X. Okay. Looking at C, and for part B, your reasonings could be different. Part C, it says find the perimeter of each figure, write the perimeter in simplest form by combining like terms. So go ahead and pause your video and try part C. Okay, if you're back with me, you've done the perimeters. So I'm going to, the perimeter for 1 is 4x plus 2 units. Perimeter for 2 is 2x plus 4 units. Perimeter for 3 is 4x plus 6 units. And those are in simplest form. So if you did not get those, we will discuss those in class. But for the future questions, make sure you are using the perimeters that I have given you. Okay? 6102 says in any expression, the number that tells you how many of each variable or quantity you have is called a coefficient. For example, for the expression that describes the collection at right, the coefficient 3 shows that there are 3, this should say x squared tiles. And the coefficient 4 shows that there are 4x tiles. The 6 is called the constant term because it is a term that does not contain variables and does not change no matter what the value of x is. Answer each question below for each of the perimeters that you found in problem 6101. So I gave you the perimeters and this part right here, this problem part C. You are going to use those to answer questions A, B, C, and D. So it says, what is the coefficient in the expression for the perimeter? So for 1, you're going to write the coefficient. For 2, you're going to write the coefficient. For 3, you're going to write the coefficient. Okay? And then you're going to continue on. You need to make sure that you're doing it for each one of those figures in the first problem. So each perimeter that you see up here, you are answering the questions down in 6102. 6102 is the last thing that you need to do for this set of notes. We are going to be saving this and talking about it in class. As always, when you are done, please upload a picture of your work. And if you have any questions, please email me.